Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Chris Flack.
Hey, thank you so much, Vicki, and welcome everybody in our audience to today's webcast, What You Need to Know When Evaluating Amazon Web Services Integrated Disaster Recovery Solutions, sponsored by CloudEndure. I'm Chris Flack with Virtualization and Cloud Review, and I'm here to be your host for today's event, so thank you all for joining. Before we get started and get introduced to all our great presenters from CGS, Amazon Web Services, and CloudEndure, just a couple quick reminders before we begin today's show. So first things first is we are recording today's webcast for future viewing and listening purposes. We will send you a link within 24 to 48 hours after the show has been over. Please feel free to share that link with coworkers, colleagues, friends, anybody who may be interested on today's topic. We would greatly appreciate that. Also, today's webcast will feature a Q&A session at the end of today's call. However, we do encourage you at any point, if you have a question for our presenters, to please enter the question via the Ask a Question box appearing on the left-hand side of your console. Hopefully, as time permits, we'll get to everybody's questions and get out some answers. Joining us for today's webcast, we have several great presenters joining us. A little bit later on today, you're going to hear from Michael Brandy. He's the Vice President of Technology Solutions for CGS. A little bit later on as well, you're going to hear from Gonan Stein. He is the VP of Business Development for CloudEndure. And you'll also be hearing from Ian Schofield. He's first up today, and he's Solutions Architect from Amazon Web Services, and he's going to begin today's program and tell us a little bit about what Amazon Web Services has to offer. So Ian, why don't you get started, my friend?
Awesome, thanks. So like you said, my name is Ian Schofield, and I'm a Solutions Architect based here out of Seattle for Amazon Web Services. And I work with our AWS technology partners like CloudEndure to architect scalable and cost-effective solutions in the AWS cloud. So to give you a little bit of background about AWS, Amazon Web Services offers reliable, scalable, and inexpensive cloud computing services. It's free to sign up, and you only pay for what you use. We currently have over 90 services ranging from machine learning to data warehousing to compute resources and many more. And we're continuing to add new services and features based on our customer feedback. One of the benefits of utilizing AWS is the ability to go global in minutes. And I'll touch on our global infrastructure in the next slide. We have regions all over the world, giving you the flexibility in where you choose to run and migrate your applications to. One of the main drivers in our platform is innovating and finding ways that we can lower our prices and in turn save our customers money. To date, we've had 62 price reductions and will continue to do so wherever possible. The AWS Partner Network, or APN, provides technical, business, and marketing support for the AWS partner ecosystem. It has tens of thousands of technology and consulting partners worldwide, like CloudEndure, who provide additional functionality on top of what AWS provides to AWS customers. Here we have the AWS global infrastructure. And the AWS cloud infrastructure is built around the concept of regions and availability zones, or AZs. A region is a physical location in the world where we have multiple availability zones. Availability zones consist of one or more discrete data centers, each with redundant power, networking, and connectivity, housed in separate facilities. These availability zones offer you the ability to operate production applications and databases which are more highly available, fault-tolerant, and scalable than will be possible from a single data center. The AWS Cloud currently operates 44 availability zones within 16 geographic regions around the world, and we're continuing to expand with new regions and AZs coming online. We also currently have 100 edge locations, which are part of Amazon CloudFront, our content distribution network. I'd like to touch on Amazon Elastic Compute Cloud, or EC2, as it will play a fundamental role when using the CloudEndure product. Amazon EC2 is a web service that provides secure, resizable compute capacity in the AWS cloud. You can provision hundreds or even thousands of servers in minutes from any of our 16 regions around the world. Customers can leverage features like auto-scaling to match the demand of their platform. This elasticity allows for customers to save money by not having to over-provision for peak usage, but still have the ability to quickly provision new resources to meet their demand. Amazon EC2 comes with various pricing models, ranging from on-demand for pay-as-you-go pricing to reserved instances that allow for deep discounts of up to 70%. Within Amazon EC2, you have the choice of multiple instance types, operating systems, and software packages. EC2 allows you to select a configuration of memory, CPU, instance storage, and the boot partition size that is optimal for your choice of operating system and application. For example, your choice of operating systems includes numerous Linux distributions and multiple versions of Microsoft Windows Server. In this case specifically, we allow you to create your own Amazon machine images to migrate existing workloads and run them on EC2, which we'll talk about a little bit later when reviewing the CloudEndure product. This is just a small sampling of the various types of instances we provide, including micro-instances, general purpose, compute optimized, storage optimized, instances with dedicated GPUs, including our P-series and G-series for graphics and general purpose GPUs, and memory optimized with up to 4 terabytes of memory for our X1 instances. We also have instances with FPGAs. We touched on EC2, but I'd like to provide you with an overview of Amazon Virtual Private Cloud, or VPC. This is where a majority of the resources you create will live within the AWS cloud. Amazon VPC lets you provision a logically isolated section of the Amazon Web Services cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual networking environment, including the selection of your own IP address range, creation of subnets, configuration of route tables, network gateways, and so on. You can easily customize the network configuration for your Amazon VPC. For example, you can create a public-facing subnet for your web servers that have access to the internet. You can place your backend systems such as databases or application servers in a private-facing subnet with no internet access. You can leverage multiple layers of security, including security groups and network access control lists, to help you control access to Amazon EC2 instances in each subnet. Additionally, you can create a hardware virtual private network or VPN connection, or utilize our Direct Connect service to provision a dedicated connection between your corporate data center and your VPC. Either of these solutions allow you to leverage the AWS cloud as an extension of your corporate data center. Lastly, the AWS cloud has been architected to be one of the most flexible and secure cloud computing environments available today. AWS is certified and accredited by a wide range of regulatory and industry bodies. Here are a list of key bodies that have either certified us, or we have a workbook of guidance showing you how to validate an AWS environment against these standards. And all AWS customers inherit all the best practices of AWS policies, architecture, and operational processes built to satisfy the requirements of our most security-sensitive customers. With that, I'd like to hand it over to Gonan from CloudEndure to tell you more about the product and how it can help you with disaster recovery and live migration.
All right, thanks so much, Ian. So hello everyone, this is Gonan Stein here from CloudEndure. I'm going to speak briefly just to give everyone a very high-level idea of who we are and what we do at CloudEndure, and then I'll hand it over to my friend Mike at CGS, and then we'll talk about more detailed CloudEndure, how things happen behind the scenes later on in the discussion. So from a high level, CloudEndure is a technology company. We focus on live workload mobility. And first and foremost, we are a cloud-based disaster recovery company. We'll talk about that in detail today. We also have live migration capabilities to our solution. And the things that our partners and customers find very compelling about CloudEndure is that we really make things very simple, irrespective of what the infrastructure is or what the applications are. We can support physical servers, we can support virtual servers, we can support any kind of cloud infrastructure, both as a source and as a target, both for continuous protection for disaster recovery as well as for migration. There are capabilities for both failing over and failing back when disaster is over, and the product is available for consumption in many different mechanisms, including the availability on the Amazon Marketplace, both as SaaS contracts as well as monthly pay-as-you-go subscriptions. And the way that we work with AWS is that for many years now, we have been working with AWS as a cloud provider. We are an advanced technology partner, and we're part of the APN network under the different relevant competencies, both storage and migration. And later on today, I'll talk about the specifics of CloudEndure. But with that, Mike, I'll hand it over to you.
Good afternoon, everyone. This is Michael Brandy from CGS. I'm here to tell you a little bit about our journey with CloudEndure for disaster recovery as a service, as well as our journey to the cloud. But before I do that, let me tell you a little bit about CGS. So CGS is a technology solutions company. We've been around for 30 years. We're headquartered in New York City. We've got approximately 7,500 employees globally and over 3,500 customers, servicing a wide range of industries. And as is obligatory in most of these presentations, I'll give you samples of some of our clients and what we do. But you can see from this key relationship slide that we span multiple industries, from technology to consumer products to apparel, soft goods, healthcare, really wide spectrum of customers that we touch on a day-to-day basis. The types of services that we provide for these customers are managed cloud, application development, outsourced managed services of their on-premise infrastructure, enterprise infrastructure projects, things like your traditional migrations, VMware upgrades, server deployments, network upgrades, etc. And we also have email archiving and cybersecurity practices within the company as well. I want to speak a little bit about one of our divisions here at CGS. It's our Application Solutions division, and this is really where our journey with CloudEndure and AWS started. So our Application Solutions division has a product called Blue Cherry. Blue Cherry is a ERP product used by the software and apparel industry, mostly throughout soft goods. The product is based on Microsoft technologies, .NET, SQL, IIS, very traditional type of technologies. And we've been offering this product since around 2000. In 2008 or so, we realized that we needed to have a SaaS-based offering or a cloud-based solution for the product, and we decided to go to the cloud. At this point, we partnered with several different providers to provide the services, but really were unable to get the type of performance and service that was needed for an ERP application. 2008 was a little bit early for some of the cloud providers. They couldn't really deliver on high-performance SQL environments and that sort of thing that's required for ERP. With that, we decided we'd go at it on our own. We decided we'd build our own hosted platform and offer things directly to our clients. So how did we do that? Well, being an enterprise infrastructure and solutions company, we did it in a very traditional way. We had co-location services. We leveraged Dell servers, EMC storage, Brocade switching, Cisco networking, F5 load balancers, really your pool of your typical enterprise providers in the space. And the environment was built to be highly reliable and high performance. Now with that, we also needed to have a disaster recovery solution. As we were hosting customer data, it wasn't possible for us to just say, sorry, your ERP system's down. That's not really an acceptable answer, right? So we used, again, very traditional enterprise types of solutions to back up and provide disaster recovery for the environment. What we were using was Veeam backups for local backup and replication to a secondary facility. We were using EMC MirrorView for SAN-based replication for runs and things of that nature that were not able to be snapshotted by Veeam. And we also used SQL log shipping to keep SQL logs in sync. This is to say that we had a secondary facility on the other side of the country with duplicate hardware, etc. So over time, we became successful. That's a good thing. That's a good thing for everyone. We built up more clients in our hosting business, and our SaaS business grew, and it grew. Where it got to the point that we started to have some concerns about our recovery time and our recovery point objectives. The environment was getting big. Snapshots were becoming cumbersome. Replication was becoming difficult. Managing all the different technologies to keep everything in sync, making sure everything worked, making sure everything was tested, became a real burden to the team, and it also became a little bit unreliable in some aspects. So we had a bunch of challenges in this environment. As I said, we had a secondary facility, duplicate equipment. That can be extremely costly. Every time you're buying compute resources, storage resources, you're buying two, you're expanding space, you're increasing data lines. This builds and builds and builds to a point that it was starting to become too costly to continue to operate in this manner. We also were having replication issues. Things would fail. A portion of those three solutions wouldn't go over. We realized that this was not something that would scale and not a way that we could continue to operate long term. So we decided it was time to evaluate different solutions. The first challenge we had in evaluating solutions was convincing management and our technical staff that we no longer could continue to operate the way that we were. There was, being a technology company, a lot of pride invested in this, that the team wanted to continue to do things on their own. They weren't necessarily ready to move to the cloud. We realized that this was something that was required in order to be scalable and continue to grow the way that we were. So we went and started to evaluate different cloud providers. We looked at all the major providers, Google, Microsoft, AWS, and I'm sure you can guess by who we're partnered with for this presentation where we wound up, but I'll tell you a little bit more about that journey. We also looked at different solutions to provide the replication and backup services, so solutions from native scripting through Zerto recovery, Veeam solutions, Azure Site Recovery, all different solutions were presented and evaluated by the team. The requirements that we laid out for this were the solution had to be public cloud-based. We knew we didn't want to have a secondary data center. We could not do snapshots. We really needed continuous data protection. We were dealing with ERP customers. We were moving billions of dollars a day through our environment. It wasn't something that we could continue to have periodic backups, periodic replication. We also needed the process to be fully orchestrated. This is a real key point here because we didn't want an environment where you could fail over to a public cloud and then you had to run all sorts of scripts, have a whole bunch of manual intervention, have a whole runbook that people could potentially have mistakes or errors in bringing the environment online. And the solution had to have easy testing and verification. With that, we embarked on the journey and we had demos from pretty much every provider out there. This allowed us to eliminate some solutions right off the bat. After we got past the demos, we asked people to show their solutions. When we asked people to show their solutions, we were narrowed down to Azure Site Recovery and CloudEndure on AWS. When we got down to these two different solutions, we decided it was time for a POC. We asked both vendors for licenses and acceptance to do a POC, and we began the process. What we learned during the POC process is we're a little more complex than we realized. In building an ERP environment for high availability and performance, we had all sorts of clustering technologies, high availability set up from SQL clusters, file clusters, DFS, IS web farms, always on availability groups. And each one of these different technologies added a little nuance that made different solutions more difficult to implement. So the evaluation outcome, as I said before, you can guess who we selected. We selected CloudEndure and AWS, but why did we make that selection? What were the deciding factors that went into it? As I said, some of those complexities before, the clusters, that was something that was very difficult for different solutions to handle. How do you replicate clusters, active, passive, or always-on availability groups? Large file stores, Azure Site Recovery Manager, when we tested it, had a lot of difficulty replicating large file stores and applying NTFS permissions. The solution there was to use Store Simple. That became a little bit more convoluted and complex of a solution than we wanted. And then the second part was automation. The automation, once the data was replicated to the cloud environment, the ability to orchestrate a full recovery was critical. AWS and CloudEndure really delivered on that, particularly with the automation and orchestration. So where are we today? We have a recovery time of under 30 minutes. We can actually provision environments in less than 30 minutes. That is from pushing a button for the CloudEndure machines to spin up all the different virtual machines that are defined in what they call blueprints. So Goning will give you a bit more information on that as we go through the rest of the presentation. We have continuous data replication. So our recovery point is less than 3 minutes. The data is continuously replicated to the cloud. It's always there, always available to be failed over to. We've reduced our disaster recovery costs by over 80%, and that's a big one. That was very significant for the organization. And the scalability. This has really allowed us to scale without having to worry about that secondary facility and always purchasing hardware, et cetera. A little bit about CloudEndure. The application, a lightweight agent that gets installed on the operating system level. This does block level reads and transmits the data immediately. There's almost no impact on the system performance. It's real time and very simple to configure. So after this, we've now migrated over 200 of our customers to AWS and CloudEndure. We're leveraging CloudEndure not only for disaster recovery, but also to migrate production workloads. So we're in the process of migrating production workloads to the AWS cloud because we've had such a good experience with disaster recovery as a service. And from all the experience we've gained in this process, we're offering disaster recovery as a service to our clients, and it's become one of the core offerings of the CGS Technology Solutions practice. So we're actually going out and being a service provider in the industry, and this has been added to our portfolio. A little quote from me about the orchestration. I can't emphasize this enough. The ability for a product to provision all the virtual machines exactly with the specifications you want, put them on the networks you want, run scripts, and automate the entire process of recovery is key. The lack of human intervention really cuts down on errors and problems when you're failing over, particularly in a disaster scenario. A little more proof of concept. Pretty much everything we've spoken about before. You've got automated orchestration, cloud conversion. So any to any, you can take a VMware or a physical machine or a Hyper-V machine and convert it to AWS format as part of the blueprints. This is all part of the orchestration process. And some notes and tips on things to look at when you're making these types of selections. Ask DR vendors, if they can work well with databases, clusters, both physical and virtual machines, different OSs, large disk size, and of course, ask about failback. I guarantee every single one will tell you that they can. I advise that you dive into the details, go through it, ask to conduct a POC, see the products in action, make sure they can actually live up to the potential that the salesperson is telling you about. Evaluate real workloads. When you're doing your POC, don't just set up some demo server and do it. Use a real representative workload in your environment. Have your end users test that failover, make sure it actually recovers, it actually performs once you've failed over. And like any disaster recovery solution, I can't mention this enough time, make sure you test your failover regularly. It's not enough to have a solution. If it's never been tested, you won't be able to operate in a disaster scenario. So please, just make sure you always go through testing. And with that, I will pass this over to Gonan at CloudEndure to tell you a little bit more about how the product actually works.
Excellent. Thanks so much, Mike, for all the detailed information. So with that, let me start walking everyone through what we do at CloudEndure and start talking about the details. So as I mentioned before, the primary focus of the company is to provide a disaster recovery, robust enterprise-grade disaster recovery capability leveraging cloud. And this is built on different technological pillars that are very unique to CloudEndure that make the process very simple and robust based on what Mike had mentioned before. So if you look at CloudEndure's technology, there are multiple key technological pillars that the product is built on to make everything happen and to make everything very simple. The first technological pillar behind CloudEndure is the ability to replicate continuously at the OS level. And what that means is that, as you've heard before, there's an agent that gets deployed on the source machine. Any supported version of Windows or Linux would be fine, irrespective of the application. Right? So when you deploy the agent on the source machine, first off, we don't care what the source infrastructure is. So it could be physical servers, it could be virtual servers on any hypervisor, it could be cloud-based machines, so that doesn't matter at all. And since we replicate at the block level, it also is agnostic to the application. So very commonly, we see our customers replicating very complex databases such as SQL servers, and CGS has done, and Oracle databases, and SAP workloads, and custom homegrown applications, and it's all transparent to us because of our replication at the block level, and it's continuous. So every block that gets committed to the source machine, any database transaction or registry setting change, or files that are updated on the machine, everything is captured at the block level and replicated asynchronously and immediately in real time into the target cloud location of your choice. Then on top of that, we have the ability to minimize the footprint of the replication environment in the target location, and this is key because in the traditional world of disaster recovery, it was very common to have to maintain duplicate infrastructure, duplicate compute and duplicate storage and duplicate software licensing in many cases, and that resulted in a very expensive disaster recovery solution. The whole point about cloud, which Ian had mentioned before, is that you're paying as you go. You only need to pay for what you're actually using at that given point in time. And CloudEndure takes full advantage of that. When we replicate the data, we replicate just the data and keep it stored in a very low-cost storage environment in AWS. And only when disaster strikes, we have the ability to perform a very quick, rapid machine conversion process, which you can see here as well, a 1-minute any to cloud image conversion process, which takes the source machine, irrespective of where it came from, whether it's VMware or Hyper-V or physical machines or other clouds, and we convert it to Amazon format very quickly, also irrespective of the size of the machine. And we complete the full-blown orchestration of standing up the application stack. And then finally, in terms of our technology, it's designed for busy databases, busy applications without impacting performance of those source machines in any noticeable way. And that's also a very common question that comes up with our enterprise clients. What kind of impact is it going to have on my production applications, my databases? Is it going to have to reboot my systems or not? So with CloudEndure, there is no reboot requirement at all, not during installation, not during upgrades. It's all in place and non-disruptive. And it's designed for very busy, write-intensive applications without impacting the performance of the system. So if we kind of summarize the benefits of using cloud for DR, leveraging CloudEndure, the whole cost reduction element is going to break down how we're able to reduce the cost so dramatically, both around compute and storage and the fact that there are no duplicate licenses that you need to provision for operating systems and applications. Networking is also essentially provided at no cost when you're creating your target networks in AWS. Most of the networking components are free, as long as you're not spinning up compute or storage resources in there. The RPOs and RTOs are very aggressive. So recovery point objectives in the sub-second range, recovery time objectives in the minutes range, no impact and non-disruptive testability. That's also key to a lot of our clients, the ability to perform DR drills without impacting the source application. In the traditional world, it is very common when you're conducting your DR drills that this, one, stops the replication from happening, and then if you have a real disaster during that test, you're losing data. And two, it would, in some cases, require the shutdown of the source machines. With CloudEndure, there is complete non-disruptive testability, where you can bring up the machines in the target location in AWS without impacting replication or impacting the source machine. In addition to that, failover, failback, we talked about that before. So it's one thing to be able to fail over into AWS at the time of a disaster. It's a very different thing to be able to fail back once disaster is over, failing everything back, including all the data that had changed in the cloud during the time of that disaster. So CloudEndure can do that as well. Extremely simple to deploy and no need for re-networking during disaster recovery tests or actual disaster events. So that's what the technology does. I know this is a lot of content, but I wanted to make sure that we walk through what the capabilities are. In terms of the workflow with CloudEndure, the way that this works from a high level is that the first thing you'll need to do is assess what machines you want to protect, what machines you want to replicate. Once you've assessed what you want to replicate, you can deploy the agents, the CloudEndure agents on the source machines, which can be done either manually or in a mass unattended fashion using any deployment tool of your choice. As I mentioned earlier, there is no reboot, no performance impact, and also very importantly, nothing to configure. There's nothing you need to configure around the operating system or the application or the database. It's all done at the block level, so that's transparent. And once you install the agents, the data starts to get replicated continuously into that very lightweight staging area, that low-cost environment in the target cloud location. And while that's happening, you can configure what we call the blueprint. The blueprint will eventually dictate where each machine belongs when you need to use it, when you need to launch it in the time of a disaster, and how it should be provisioned. So what instance types it should use, what storage device type it should use, what IP addresses should be assigned, and so on. And once you configure that blueprint, it's really easy to test the target machine, to launch it, and make sure that it's working as you expect it to, that the application is functional, that the performance is looking good. And if for whatever reason you've made a mistake and you've spun up the machine in the wrong location, maybe it's in the wrong subnet and one server can't communicate with another server, the database is inaccessible, or maybe the domain controller is living in a different subnet and you need to change that, no big deal. You can go back, correct the blueprints as needed, so change it to a different subnet, upsize or downsize the instance types if you're over-provisioned or under-provisioned. It's really simple. And rinse and repeat until you're happy, until your application is functioning as expected. And when it is, then you can set it and forget it. Then there's nothing more to do but put it there and wait for the time that an actual disaster strikes. And then you can simply repeat that test, but cut over. So spin up the machine one more time and cut over or fail over into the target cloud location. So that's how the process works from a high level with CloudEndure. What I want to show you on the next slide is how things look like under the cover, so what the reference architecture looks like with AWS. So everything starts with CloudEndure with a CloudEndure console account. So you open up a CloudEndure account within the CloudEndure console, and within your account, you can start to define what source location you want to replicate from, which could be anywhere, right? Physical, virtual, or cloud-based machines. And once you define the source location that you want to replicate from, then you can define the target location that you're replicating to. So let's imagine that our DR site is going to be at Amazon US East region. So in the Amazon US East region, what you'll need to do is define a subnet, a network subnet, which is going to behave as a staging area. This is where CloudEndure is going to replicate the data. And that's it. There's nothing else that this subnet is going to do. This is not where the machines end up living and being used later on. This is just that replication server subnet, that staging area. And there's nothing that you need to create in that subnet. Just create the subnet itself and provide the subnet ID into the CloudEndure console configuration so that we know where to replicate the data. Once that's done, you can get started. You can install the agents on the source machines, deploy them on Linux or Windows machines. Once the agents get deployed, they will detect all the disks attached to those machines. So we have 3 disks attached to the upper machine here and 2 additional disks attached to the lower machine. And those agents will communicate up with the console and say, hey, Mr. CloudEndure console, here we are. We belong to customer A or B, and we need to know where to replicate our data. And at that point, the console says, okay, thank you for authenticating. I recognize you. And it makes an API call to the appropriate cloud target, the appropriate account, and the appropriate region, and automatically and programmatically via API calls, it orchestrates the creation of that replication environment. And that replication environment is that very low-cost environment I've mentioned before. So it's using lightweight compute instances, Linux-based compute instances that are responsible for keeping the data in sync. The replication traffic will start flowing. It flows via a private connection most commonly. We can also go over the public internet, but mostly with our enterprise clients, we see clients using private VPN connections or direct connect. That's all supported by CloudEndure. The data is always encrypted in transit, and it can also be encrypted at rest using AWS EBS encryption. That's the Elastic Block Storage Device encryption using your own custom keys. And that's basically the footprint which gets created in that staging area, and that tiny cluster of replication servers will scale up and down as needed in a many-to-one ratio. So for many machines replicating from the source, we create single machines over in that replication staging area. So that's step number 1. Step number 2 would be to configure the blueprint. That's the information of where the machines belong eventually when you want to spin them up and use them. So what target subnets, what target IP addresses, what instance types, what storage device types, public IPs, elastic IPs, and a lot of other properties that you would expect to be able to control. And once you've configured that blueprint, you can proceed to step number 3, the last step, which is launching the target machine. So at the time of disaster, or at the time of a test, you can select which machines you want to bring up, and it's not all or nothing. It could be specific individual machines, it could be groups of machines, it could be partial. You can select what it is you want to bring up, and that triggers a different set of API calls that CloudEndure's console will send to the appropriate Amazon account, which actually now orchestrates the creation of the entire stack. So what we're doing behind the scenes is we're taking these volumes that are replicating in real time from that into that staging area. So we're snapping their most recent state and creating those volumes in the target subnets of your choice, where the machines eventually belong. This is where we're also right-sizing them, so we're using the appropriate high-performance volumes as needed. We're converting the boot volumes to Amazon formats. So if you're coming from VMware or physical or other clouds, you'll see that a tiny Linux-based machine converter instance would come up, convert the boot volumes very quickly within under a minute, and then when it's done doing its job, when it's completed the conversion process, it gets terminated, and the volumes get attached to the actual instances that are going to run those machines going forward. So Linux instances or Windows instances, depending on what your applications are running. And this is it. This is the end of the process. So now the applications are accessible. You can connect to them and validate that everything is functioning correctly. And as we mentioned before, if for whatever reason you've spun up the machines and they're not spun up in the right subnet, If you've made a mistake in the blueprint, you can simply go back to that blueprint step, configure the blueprint again, and launch the machines whenever you're ready. One other thing that I should mention here is that when you're launching your target machines, you can either launch them using their most up-to-date state, if you had a disaster and you want to recover to the state of that machine a few seconds ago. But we also have the ability to recover the machines using previous points in time, and this is very relevant for situations like ransomware attacks or hacker attacks or viruses, or just plain corruptions like database corruptions. If you had your data corrupted and you want to go back, CloudEndure allows you to go back to many previous granular points in time. By default, it's every 10 minutes within the past hour, once an hour within the past day, once a day within the past month, and so on. So this is how the architecture works, how the product behaves behind the scenes. So just to summarize, during normal operation, the whole idea behind CloudEndure is reducing costs as much as possible. So it's gaining the ability to have an enterprise-grade replication solution with near zero RPOs and RTOs with the cost of a cold standby. So the compute costs are minimized dramatically, the storage costs are minimized dramatically, OS and third-party application licenses are completely eliminated. Those are not needed during ongoing replication. And only at the time of a disaster or DR test, this is what happens where we're taking that lightweight staging area and we're very quickly right-sizing that environment, spinning it up in the right place, and orchestrating that rapid recovery. So with that, I wanted to, first of all, thank everyone for joining. And before heading into the Q&A session, I wanted to also let everyone know that if anyone has any additional questions about the CloudEndure DR service and you want to schedule a one-on-one demo, you can contact us or you can contact our partner, CGS. You can see the contact info below. And we're also, for the participants of the webinar today, we're offering a very special promotion. You can see the code on the screen and you can send it over to the contact email below after the session. Anyone who's interested in actually using the solution, not just for a short test, but actually using it for an extended period, we're offering a promotion of 3 DR licenses that are valid through August 31st of next year. So feel free to leverage that promotion and contact us. And with that, Chris, I'll hand it over to you.
All right, excellent. Thank you so much, Gonan and Guy. Thank you so much for your presentations for today's webcast so far. So just a couple quick reminders before we start getting to all the questions from the audience. A couple people asked, the slides are available in the dock of your screen down there in the resources area. Please feel free to go down there and take the slides away today from today's program. That way you can have a copy of the code and everything that you see here in the thank you slides. So please feel free to take a copy of the slides away with you today. Okay. So we've got some questions here, and I'm going to start to fire them away to everybody. So we've got all the guys joining us, so I'm going to fire the question out there. All of you guys, Gonan, Ian, Mike, feel free to chime in when you want to. We've got some questions here for some specific guys, so I'll try to point those questions out to you guys specifically, but everybody feel free to chime in. Okay, so the first question that we have here that we're asking is how many resources or how much resources are used for an agent on a source host? How many resources are used?
Yeah, sure, I'll take that. This is Gonan. So the resources that the agent consumes is a fixed 100 megabyte memory buffer, a RAM, and less than 1% CPU utilization.
Along the same line, a question here, what is the minimum internet connection speed that you would recommend that is required to make cloud-based DR functional, and what do you think the recommended connectivity would be?
So the answer will vary.
Oh, go ahead.
Yeah,
go ahead.
Yeah, Ian? Yeah, so the answer from my side is that the answer will vary based on the change rate of data. So CloudEndure can essentially operate in an environment with an extremely low bandwidth, but if the data changes at a higher rate on the source machine, it's more a matter of the restrictions of physics. The data wouldn't be able to get pushed fast enough to the target location. So it all depends on the change rate. And Mike, if you wanted to add anything else, please chime in.
I was going to say the same thing. It's relatively low when there's not a lot of changes. We operate close to a petabyte of storage, replicating continuously with a 1 gig line without that being saturated, and we have a pretty high rate of change, if that gives you an idea. The first replication obviously takes a little bit longer because you have to, put all the data on the other side. But because it's continuous and block level, the amount that's transferred once that initial replica is created is pretty minimal. So you can get by with not a huge connection.
I'll direct this question towards Ian. The other guys could chime in as well. What is the cost difference for housing disaster recovery in AWS versus running the actual workloads in AWS? Do you have thoughts on that? And the other guys could chime in as well.
Yeah, so from an AWS perspective, we try to stick to, and we do stick to in all our resources, that you only pay for the capacity that you use. So for the data that's stored in S3, you're only paying for those blocks that you're actually storing. If you're not running the EC2 instances, then, if you're not running the EC2 instances, you're not having to pay for that compute capacity. The second that you do spin up those EC2 instances, then you will start being billed for the EC2 usage. And CloudEndure can kind of talk a little bit more how the offering works and what that S3 storage looks like.
All right, excellent. Thank you so much. We've got a question here, and somebody was asking, could you go into a little bit more detail, please, and discuss the minimal footprint replication staging area a little bit more, please?
Sure. Yeah, I'll be happy to answer that. So essentially, for every roughly 15 source volumes that are being replicated, CloudEndure creates a single small Linux instance. It's using T2 small Linux instances in the target environment. So that's on the compute side. Typically, you're going to see a compute reduction of over 99% versus a warm standby. And then on the storage side, we use either a magnetic EBS volume or an ST1 EBS volume. So these are low-cost elastic block storage volumes. Even if the source volumes are high-performance volumes, that doesn't matter. The target volumes in the staging area will always be low-cost volumes, and we will right-size them whenever the disaster strikes based on what you defined in your blueprint.
All right, excellent. Thank you so much. Everybody, please feel free to keep firing your questions in. We appreciate them. Let's see. Oh, don't forget, you can go down to the bottom and take the slides from today as well. Okay, question here. This person was asking, can production stay up during DR testing?
Absolutely. Yeah, there's zero impact to the production environment whenever you perform a DR test, because the DR test is going to be conducted in a completely isolated target DR location.
And another question, too, when you get into regular routing and testing, does additional licensing costs come into play?
No, CloudEndure doesn't charge anything for tests. You can perform tests on an hourly basis.
And this is Mike. Just as a note, there are obviously the costs of the AWS infrastructure when you spin up those instances while testing, but that's minimal because generally testing is just for a short period of time. You're not running those workloads for any prolonged duration.
Yeah, thanks, Mike. Yeah, that's correct. Obviously, any resources that start to get utilized in your Amazon account are resources that you will be charged for throughout the duration of the test.
I believe this question was for Ian. They asked it in the beginning of the webcast, so apologies if it's not. But Ian, this question was, is DR available only for EC2 types of service? They were looking for a data backup and replication on AWS managed services like AWS IoT and AWS DynamoDB.
Yes, for some of the other services, you can use some of the other AWS services. So if we take a look at AWS DynamoDB, we could use something like DynamoDB streams, and we can write that data to S3, or we can, with the IoT service, we can dump it into Kinesis Firehose and store that data in S3. So there's a number of different ways you can go up backing up those services, natively with AWS, as well as other partner solutions that kind of focus in these key areas to provide you additional functionality.
We got a question here. This person was asking, Gonan, how do I get pricing for CloudEndure? Do you have any more information?
Sure. So you can get pricing both through our partners like AWS and CGS. Pricing is also available on the AWS Marketplace.
All right, we've got a question here from the audience. What are the licensing implications for VMware, SQL Server, et cetera?
Okay.
Sure. Mike, did you want to take that? I think you're pretty good. Yeah, go ahead.
Unfortunately, we're well versed in that. Obviously, you have to You have to look at your licensing agreements with the different providers, but most providers do not charge a license when the secondary instance is not running and allow for disaster recovery, specifically Microsoft and VMware, in the other side of the environment. You are not actually replicating your VMware infrastructure. You're replicating from the OS level, so there's no VMware implication. When you're talking about things like SQL Server, there is really no licensing cost because once it's replicated into the AWS environment, it sits in that staging area until you provision it using the orchestration to create the virtual machines. At that point, the SQL environment would come online, and Microsoft allows for disaster recovery testing in their licensing agreement.
Excellent, thanks, thank you. We've got some more questions here. Please feel free to keep firing them in, everybody. We appreciate it. So let's see, this question is asking, how long does it actually take you to switch to the Amazon Web Services disaster recovery? Do you have internal checks and balances before you cut over? What are your thoughts?
Yeah, so I think I'll answer it from a CloudEndure perspective, but then Mike, maybe you want to talk about it from a practical, real-world scenario. From a CloudEndure perspective, the time it takes to recover, to bring up the machines in AWS is going to happen in a matter of minutes. But before you actually redirect your user traffic there are typical things that we see our customers and partners doing, performing certain application acceptance tests before declaring that the environment is ready for your users to be redirected into. So, Mike, maybe you can talk about the real-world scenarios that you've tested and that you've used with our disaster recovery capability.
Yeah, I think there's really two parts of that question. The first part is how do you determine that you're ready to use CloudEndure as your production disaster recovery software and tool? That's very much what Gonan said. You would go through a failover test, validate your applications with your end users, and ensure that everything in the disaster recovery environment functions as it should. The second part of that is how do you determine when a disaster actually occurs? And that's really a business decision. Inside CGS, we have certain metrics and checkboxes that we follow to determine whether the environment can be repaired and what's an acceptable time to repair something as opposed to failover to DR. But once the failover to the disaster recovery environment is called, the process is relatively straightforward. It's an automated process, and like I said before, it takes about 30 minutes to provision all the machines, bring all the different Windows operating systems online. For application purposes, often you have to bring up certain machines before others, like databases before web servers, et cetera. And that's really the biggest portion of that 30 minutes, getting the individual machine groups up prior to the other machines coming online. So it's ultimately a business decision when the environment is ready, but going through a test process with your users before considering it ready for production would always be recommended.
Excuse me, question, Mike. What type of services can CGS offer now leveraging CloudEndure?
Sure. So CGS can help clients do a couple of things. First, we're an AWS partner. Second, we're also a CloudEndure partner. So we can help you set up your AWS environment, all the networking, all the VPC settings that need to be configured in the environment before CloudEndure can replicate. We can then help you create the CloudEndure deployment, deploying the application through your entire infrastructure, building out the blueprints with you to determine what occurs during failover, and working with you on a plan to automate the failover process. So really taking you from the beginning of the process to the end. And if needed, CGS can also monitor and maintain that disaster recovery environment for you, really taking it entirely off your hands.
Got a question for you guys. Somebody was curious. How do you handle all the DNS and IP changes during the DR switch?
So there's different ways to do it. Anything that's public DNS needs to have some sort of failover. So if you have Cloudflare or DNS Made Easy, or even update your DNS solution to point to this secondary set of IPs, that is required. There are different ways to structure the CloudEndure replication. You can have the machines replicate to different networks than they were using previously and scripts to re-provision the IP addresses, or you can have it replicate using the source IP address. There are different concerns and considerations with each of those choices depending upon how you're connected to the environment. For instance, if you have a VPN and want to do testing, you might not want to replicate the environment using the same IP addresses because that can cause conflicts. You'll have to work through that. These are the types of things that are decided during the implementation process, but you basically have different options, whether it's keeping the same IP addresses or re-IPing the systems. All of that can be automated during onboarding and installation.
All right, great. So thank you guys so much for answering all these great questions that we had today. We had a ton of questions come into the queue. So if we didn't get to your questions, don't feel bad. I'll make sure that the guys get your information and get back in touch with you once the presentation is over. I'm going to let class out a little bit early today just because you guys have hung out there with us for almost the entire hour today. So we really appreciate your time. But Gonan, Mike, and Ian, thank you so much for your awesome presentations, guys. That was a lot of fun today. Thank you so much for joining us for today's presentation. Don't forget, you could go down to the bottom of your screen to the to the resource area, download today's slides, and get the information here from the thank you slide. You could get the great offer that they're offering. You could also copy down the email address that you see there on your screen. But we really appreciate everybody's time in joining us for today's presentation, sponsored by CloudEndure and brought to you by Virtualization and Cloud Review. Gonan, Mike, Ian, thank you so much for your time today, guys. You guys are great. And to the audience, thank you so much, and we hope you have a great rest of your day. Take care, everybody. Enjoy the rest of your day.
Thanks, everyone.
Thanks. Bye-bye.
Thanks, everyone.